Part 2, this is for questions 7 to 10. Question 7, the diagram shows the curve with the equation, this one here, and the line with this equation. The curve and the line intersect at points A and B, but find the coordinates of A and B. So here we are going to solve simultaneously. They have the same X and Y coordinates, so we are going to equate. This one is equal to that, as simple as that. So I will say for intersection, then 3x minus 2 to the power of a half, then shall be equal to a half of x, then plus 1. And then from there, we shall square both sides. Square both sides such that we eliminate the power of a half. So when I get this 3x minus 2, then to the power of a half, and I square it, and also I do the same thing this side using indices. This one will multiply with this, and then it goes. So we shall have 3x minus 2 here, which is to the power of 1 also. Then we equate to, here you square this one here, it becomes a quarter x squared. Then get this 2 times this one times that, and that one will give us x. Then square the one, that one will give us a 1. Then I can now multiply all through by what? By 4 to eliminate the denominator. So this will be 12x minus 8. It is equal to x squared here, then plus 4x plus 4. I can bring everything this other side to have one quadratic equation, so that will be x squared, then 4x minus 12, that one will give us minus 8x, and then when this one comes here, it adds to the 4. What do we get? We get a positive 12, which is equal to 0. When I factorize this one, two numbers, when I multiply them, they give me 12, but when I add them, they give me negative 8. That will be negative 2 and negative 6. So x will be, here I'll put minus 2, and then here I'll put minus what? 6. So meaning x shall be equal to 2, and also x shall be equal to 6. And for each of these values, I need to get the y value. So substitute in any of the two you want. So if I use a half, then times x plus 1, this one will give us a 2, and then this one here, a half of 6, that will be a 3, plus 1, this one will give us a 4. So that means by looking at the sketch of the diagram, the x coordinate of A is smaller than the x coordinate of B. So the smaller x coordinate is a 2. That means that is for A. So A is therefore 2, 2, and then B is 6, and then 4. So this becomes our answer here. Part B, hence find the area of the region enclosed between the curve and the line. So the area is going to be, we integrate from the x coordinates we have gotten, we have 2 and 6. So that is 2 and 6. Then which one is above? When we check here, this one here is above. It comes like this, then that. So within this region here, it is above. So you get what is above, then minus what is down, because you are getting the area below this curve. Then after you will get the area below this one here, then you subtract them to get what is in the middle. So that's why we just get the one which is above, then minus the one which is down. So we have 3x minus 1, then to the power of a half, minus a half of x plus 1, and then we put dx. And then after that, we shall have 2, then 6. Then I open these brackets here. So we will have minus a half of x, then minus 1. Now, when we begin to integrate, you take away the integral sign. This will be this, you put the square brackets, you increase the power by 1, that will be 3 over 2. You divide by the new power, but then times the derivative of this one here. Because we divide, this is integration, so we divide, and there is chain rule, which we do when it comes to the differentiation of this one. So that one will be a 3 here. So in differentiation, we multiply all through. After dropping this one, reduce the power, you enter inside, you differentiate, you also multiply it. But then in integration, and since this one is the reverse of differentiation, then we divide. So that's why it finds this one here, the power down, and it multiplies with it. But not to waste time, just increase the power by 1 here, then you divide by that new power, and then you multiply by the derivative of this one here. As simple as that. Then here you'll have a half, then this will be x, then power 2, then you divide by the new power, then minus, of course this will be x here, because 1 is the same as x power 0. So when you increase the power by 1 and you divide by the new power, then you get x power 1 over 1. You see, which is that. Then what else? Now we put our limits, right? That is 6 and then 2. Simplified before we put the limits. This will be 9 over 2. Then the 2 will somersault and then go up there. So that will be 2 over 9. Then 3x minus 1. Then power 3 over 2 minus x squared out of 4 minus x, and you have 6 and then 2 here. Now let's put the 6 in there. 2 over 9. Then 3 times 6, that is 18. By the way, you'll pardon me here. When I check back here, this is a 2. It's not a 1. So allow me change wherever there is a 1. I put this 2 here. Like that. Now, let us put, so this one is going to be 3 times 6, that is 12 minus 2. That will be 16. So I'll have 16, then power 3 over 2 minus 36. Because 6 squared is 36, then divide by 4, that will be a 9. Then minus the 6. And then minus, let us put a 2. So 2 over 9 into 2 times 3, that will be 6 minus 2, that will be a 4. Then power 3 over 2. And then minus 2 squared, that will be a 4. Divide by 4, that is a 1. Then there is a minus 2 here. Okay. Now what do we have here? 2 over 9 square root of 16, that is a 4. 4 cubed, that is a 64. Then 64 times 2, that is 128. So 128 here over 9. Then minus, this will be 15, minus 9 minus 6. Then minus square root of a 4 is a 2. 2 cubed is 8. 8 times 2, that is a 16. So we have 16 over 9. And then this one is going to be minus 3. But with this minus here, it is going to become a plus. So plus 3. Now altogether, what do we have? 128 out of 9. Then minus 15, minus 16 out of 9. And then plus 3. 4 over 9. 4 out of 9. That is our answer there. Question 8, part A, the curve y is equal to sine x is transformed to the curve y is equal to 4 sine into a half of x minus 30. Describe fully a sequence of transformations that have been combined, making clear the order in which the transformations are applied. Now, I'll begin with y, which is equal to sine x. Then next, I can have 4 sine x. So since I'm multiplying something on this y, that is a stretch. A multiplication is a stretch. Multiplication and division, it's a stretch. Then addition and subtraction on x or y, that is translation. And then the change of sign on x or y is reflection. So this is a stretch. So I will say this is stretch by factor 4, then parallel to y-axis. Okay, then y2, I can go to this one here, and we have sine, then I do something on the x, that is a half. Okay, this one here is going to be, it's a multiplication on the x. So if it is a multiplication on the x, then we are going to have a stretch. So this will be stretch by factor. For if we are having y is equal to f of x, I mean f of ax, this is a stretch by factor 1 over a. Okay, stretch by factor 1 over a. So this will be 1 over 2, not so? That will be then a 2. So stretch by factor 2, then parallel to x axis. And then what else? We go to y3, 4, then sine of this is a half of x, then minus the third. So this one will move to the right. This one will now be a translation because there is a subtraction. Okay, so translation by vector 30 degrees and then 0. Remember, when this one comes into here, it changes the sign. Okay, so that is that. Then alternatively, we can have it this way. I can begin, this is my y is equal to sine x. Then I can start with the stretch on the x here. So y is going to be equal to sine of a half of x. You see, half of x. So this one is going to be the stretch by factor 2 parallel to x-axis. Okay, then from there I'll put on this translation now. Then y, this is y1, then y2 will be sine. When you know the translation that I'm going to put on this one here, the x is already halved. So I'm putting something on it, but it already has the what? The half on it. Now for me to get to the 30 here, that means inside here, I must have a 60. Because you'll get a half of x to give you this one here, and then a half of 60 to give you the 30 here. So meaning this one will give us translation by vector 60, then 0. You see that? Then next, we can now go to the stretch in the y direction. So we shall have 4, then times this one we are having here, a half of x, then minus the 60 here. Then we have stretch by factor 4 parallel to y-axis. And by the way, this one here, we could stretch first in the y direction, no problem. I can bring this one first here, but then here, that one remains. So we can have our answer just like that. Part B, find the exact solutions of this equation here, which is equal to 2 root 2. Then for x ranging from 0 to 360, we shall take this for this side, and then we shall have sine of a half of x, then minus 30. This one will give us 2 root of 2 out of 4. Then we shall have a half of x minus 30. This one shall give us, of course, this one goes here 2 times. So we shall have the arc sine of root of 2 over 2. And this one, of course, gives us 45 degrees. But then we know that sine is positive in the first and second quadrant. Here in the third and fourth, it is negative. So this is 0. If this is 90, this is 180, 270, and then 360. If I have an angle x here, and then here, then also here, and here. So to move from here up to here, we shall say this one will be 180 minus the x. This will be 180 plus x. This one from here up to here, that will be 360 minus x. So we always look at the deviation from the horizontal axis. Okay, so we shall have 180 minus the 45. Because this one is positive, if it were negative, then we would have picked from here, the third quadrant and the fourth quadrant. Okay, then from there, our x here, this is a half of x, then will equal to, this is 45, then plus the 30, and then this one is going to give us 135. Yes, 135 degrees. Then we shall also add what? 30. And then x will be 2 times, here we get a 75. And then here we are getting 165. So that means our x is going to be 150 degrees when you multiply this one by 2. And then this one here, what do we get? So 65 then times 2, what do you get here? 10, then put here 1. That one will be 12, 13, then take here 1. It's 2 plus 1, 3. So we have 330. So 330 degrees. That is that. That is that. Question 9 is coming from coordinate geometry. The equation of a circle is this one here. Part A, find the coordinates of the center of the circle and the radius. Hence, find the coordinates of the lowest point on the circle. Now, we are going to complete squares on x and y. So I will have x squared here plus 6x. I can separate x from y, then minus 2y. Then I can take this 26 this side. You divide this one by 2, so x plus 3, then bracket squared. You pop this one out as a square. And then you also come and do the same here, y. Then minus. When you get this, the 2 there, you divide it by 2, you get a 1. Then you pop it out here as a square. Then this one is equal to 26. This whole thing here, okay, is equal to this when you expand. So we shall have x plus 3 squared, then plus y minus 1 squared. This is equal to 26. When this one crosses, it adds to this. And also this one crosses and it adds to this. So we shall have x plus 3 squared, then plus y minus 1 squared. This one is going to be equal to 36. So by comparing with x minus a squared, then plus x minus b squared, which is equal to r squared, this is the general equation of a circle with center AB and then radius r. So that means the center of this circle is going to be, you look at this one here. This is minus a, but then here it becomes a. So that means it changes the sign there. So this one, if it is positive, then it has to become a negative, right? Because the negative has become a positive. So we shall have negative 3, and then here, positive 1. So that is the center of the circle. And then the radius is the square root of what is here, because whatever is here is r squared. So that will be a 6. So that is that. Then they are saying we find the coordinates of the lowest point. So if I have this circle here, circle is here, its center is negative 3, 1. There is a radius here, which is how many units? 6 units. So the coordinates of the lowest point, the x coordinate here is going to be negative 3 minus the 6, because you are going down. No, actually, the x coordinate is still negative 3. Pardon me here. Then the y coordinate, you have this one here, subtract off the 6. Okay? So minus the 6, because this one is 6. The highest point then will be the y coordinate you have here, then plus the radius. You see that? So this one here is the lowest point. So this simply implies that our lowest point is going to be, what do we see? Negative 3 and then negative 5. And that is that. Part B, find a set of values of the constant k for which the line, this one here, intersects the circle at two distinct points. Now we have y, which is equal to kx minus 5, and we also have x minus, or I can use this one here. I can use either this one here or this one here, okay, whichever I want. So maybe let me use this one here, x plus 3 squared, then plus y minus 1 squared, which is equal to 36. So for intersection, we are going to solve these two simultaneously. For intersection, I will have x plus 3 squared, then plus, where there is y, I put kx, then minus 5, then minus a 1 squared, which is equal to 36. We have x plus 3 again here squared, then plus kx, this will be minus 6 squared, which is equal to 36. Now when we open the brackets, this will be x squared, then plus 2 times x times 3, that will be 6x, and then square this one here, that will be a 9, then plus square this one here, you have k squared x squared, then 2 times this times that, that will be minus 12 kx, then square this one here, that will be a 36. Not so, then is equal to 36. That means this one will go. Then when you put these ones together, we try to form a quadratic from here. So we have 1 plus k squared, then x squared. Okay, the coefficients, I'm factorizing out the x squared. So there's a 1 here, and then there's k squared there. Then we have plus 6 and then 12k, therefore x. So 6 minus 12k of x here. And then remember, this one disappeared. We have a 9 here. So plus 9. This one will be equal to 0. Then they said for these ones are intersecting at two distinct points. So for two distinct points of intersection, then b squared minus 4ac must be greater than what? 0. Remember, we are substituting in this formula here, minus b plus or minus to the root of b squared minus 4ac out of 2a. If this discriminant b squared minus 4ac is equal to 0, that means this whole thing will go and we shall have only one point of intersection, one real repeated root, which is minus b out of 2a. You see? And then if this one is positive, that means we shall get the square root. We shall be in position to get the square root in the real system. And then we use the plus and then we use the minus. That is where we shall get the two distinct points. But if the discriminant is a negative, you're going to get the square root of a negative, and you are not going to get the what? the real values, you will instead get the complex roots. You see that? So here we are talking about two distinct points of intersection. We shall have our discriminant greater than what? 0. So what is our b from here? This is the 1. So it will be 6 minus 12k. We square it. Then minus 4 times our a is 1 plus k squared. And then our c is a 9. Then this one has to be greater than 0. So when we open the brackets, square here, you will get 36. Then 2 times 6, that is 12, times negative 12k, that will be minus 144k. Square this one here, it will be 144k squared. Then this is 36 times 1. We shall get this minus 36 here. And then again minus 36 times the k squared. We shall have minus 36 k squared greater than 0. 144 k squared minus 36 k squared, that one will give us 108 k squared. Then this is a minus 36, and then this one, they will go, and then we remain with this one here, minus 144 k. This is greater than 0. Now we can see a 36 going into 108 and also 144. So I can put out the k here because it is also common in here, okay? Then we can have this one will be 3k, and then this one will be a 4 here, greater than 0. So by equating this one to 0, I'll get my k as a 0. Then when I equate this one to 0, I'll get 4 over 3, okay? These are the critical values. Now, since here, by the way, a mistake that is done here, people get this, they equate to 0. In fact, they say, the way they solve quadratics, so they say 36k is greater than 0. Then again, 3k minus 4 is greater than 0. The moment you do that, you fail, okay? So what you do, you just get the critical values, because here we are looking at regions where this one comes out to be what? Positive. So if you have 0 and then 4 over 3, we have to look at a region below 0, then the region in between, and then the region above, okay? So what we are going to do, because this one is quadratic, look at the coefficient of k squared. It is positive. That means you're going to have a U-shaped curve, okay? Then where it meets the k-axis, we are going to have the 0 here, then the 4 over 3. So in this region here between 0 and 4 over 3, it's negative because it's below the k-axis, okay? Just like you can have the x and y axis. This is x, this is y. Then y this way is negative if it is below the what? The x-axis. And then above x-axis it is what? Positive. So that means this one is positive and this one is positive. So for any value that goes this way, this curve continues to go that way. So that means the value of k will be positive. You see that? The same thing this way. You get any value this way, this one is continuing that side, and then you get the k value, which is what? A positive. So this simply implies we are supposed to pick regions where we are seeing something greater than what? 0. That is the plus. So it is here and then here, you see? So that means our answer is going to be k less than 0, this part, and then this part here, k has to be greater than 4 over 3. In other words, smaller than the small value and then greater than the big value. Question 10. The equation of a curve is such that the second derivative is equal to 6x squared minus 4 out of x cubed. The curve has the stationary point, this one here. Determine the nature of the stationary point. So to determine the nature of the stationary point, we just substitute the x coordinate in the in the second derivative, the 2y dx squared. So this one is going to be 6, then times this negative 1, which is squared, minus 4 out of this negative 1 here, which is cubed. And we know that even power of a negative is always a positive. So that will be positive 1 times 6, that is a 6. And then all the power of a negative is always a negative. So we shall have negative 1 here. So negative 4 over negative 1, that will be a plus 4. Okay, then here we shall get a 10, which is greater than what? 0. So since the second derivative is greater than 0, that means the stationary point is minimum. So I would say hence minimum. Simple as that. Part B, find the equation of the curve. The equation of the curve. So we need to find y. Since they differentiated 2 times, then we need to integrate 2 times. So the first integration will give us a dy dx. Okay, so it will be the integral of the second derivative here minus, this will be 4, then x to the power of negative 3 here with respect to x. So when we integrate here, you increase the power by 1, you divide by the new power. You do the same thing here. This would be negative 2 when you increase by 1, then you divide by the new power, then you put a constant here because you don't know the constant which disappeared when they differentiated, because whenever we differentiate any constant, it becomes 0, not so? Okay, so here we shall have 2x cubed, and this will be plus 2, then x to power what? Negative 2, or I can put this x down here. Okay, now this is dy dx. Now we know that for stationary points, what do you know? Dy dx is equal to 0. So this is the stationary point given. So that means when I get the x coordinate, this one here, 9 over 2 here, I substitute in the dy dx, I should get a 0. So we shall have 2 into negative 1 cubed, then plus 2 out of negative 1 squared, plus the c here should give us a 0. So this helps me to find the value of c. Okay, what do we have here? All the power of a negative is a negative. So here we shall have negative 2, then even power of a negative is a positive, then plus 2, plus the c will be equal to 0. Of course, now here c becomes a what? A 0, because this one is 0 here. That means our dy dx is going to be equal to 2x cubed, then plus 2 out of x squared. Okay, yeah, c is 0, so we leave it there. Now we integrate this one here. So y will be the integral of dy dx, which is 2x cubed, then plus 2. I can take this x up here. I integrate this with respect to what? To x. And then from there, increase the power by 1, divide by the new power. So you have 2, then x here power 4 out of 4, then plus 2, x to the power of negative 1 out of negative 1, then plus again another constant. Okay, because again you don't know what they differentiated and then disappeared before you came to this integration here. So we have here y, which is now going to be equal to a half of x power 4, then minus 2, then x, or I can say out of x. Using rules of indices, I can take this one down. Okay, then plus the k. And again, since there is this stationary point, okay, any point that is on the curve, its coordinates must satisfy the equation of that curve. So we shall have 9 over 2 here, then a half, then times negative 1 to the power of 4, minus 2 out of, this is negative 1, then plus the k. So this is 9 over 2. Of course, this one will be a 1 because even power of a negative is a positive. So when it crosses, it's a minus. So I'm taking everything this side so that I get the value of k. Now this one is a positive 2, but when it crosses, it's a negative, not so? That will be the k. So what will be k? 9 minus 1, that will be 8. Divide by 2, that will be a 4. So this whole thing is a 4. Then minus 2, what do you get? That is a 2. So k is equal to 2. So meaning the equation of the curve is going to be, I will just copy this one here, then put it here, then where there is k, I just replace it with a 2, and that is that. Part C, show that the curve has no other stationary points. Now, again, you remember that for stationary points, okay, for stationary points, we have dy dx, which is equal to what? 0. So let's go back to our dy dx, which is this one here. So it is 2x cubed, then plus 2 out of x squared. We are supposed to equate this one to 0. Then I can multiply everywhere by x squared so that I eliminate this denominator. That means here I'll have 2x to the power of 5, then here plus 2, which is equal to 0. And then x power 5 here. We shall have the 2 going this side, and the negative we divide all through by negative 2. And then we have x power 5, which is equal to negative 1. And then x becomes the fifth root of what? Of negative 1. So if you get negative 1 times negative 1 times negative 1 times negative 1 times negative 1 5 times, this one here gives you a 1. This one here gives you a 1. So again, times negative 1. So your answer here becomes x is equal to negative 1. So this is the only answer we are getting. That means this curve has only one stationary point, which is this one here. Okay? And that is that. Then part D, a point A is moving along the curve and the y-coordinate of A is increasing at a rate of 5 units per second. That means what is given here is dy dt, which is equal to 5. Suppose they said it was decreasing, that means we would include a negative here, okay? All right, find the rate of increase of x coordinate of A at the point where x is equal to 1. So we are to look for dx dt. Now, we have our dy dx, which is equal to, all right, from here, it is this one here, 2x cubed, then plus 2, 2x cubed, then plus 2 out of x what? Squared. Now, because on the curve, the gradient keeps on changing, so they have to give you a point of reference. Okay, so at this point, they have given us what? 1. Now, for x is equal to 1, what is dy dx? We shall have 2 times 1 cubed, that will be a 2, then plus 2 over 1 squared, that will be a 2. So 2 plus 2, that one gives us a what? A 4. For us to get dx dt, using chain rule, that will be dx, then I can put my dt here. But x is connected to y, so I'll put dy, then times dy dt. That means this dy can cancel with that, for you to remain with the dx dt. You see that? Okay. Now, what is dx dy? Dx dy is the same as 1 over dy dx, and our dy dx is a 4. So that means we shall have 1 over 4, then times dy dt, which is actually a 5. So that means our answer is going to be 5 out of 4. And that is that. So this has been it for this paper. Thank you so much for watching. May God bless you and see you in the next videos.